Hey guys and girls, this is Mr. Bryce, and I'm with Susquehanna Valley High School here in Conklin, New York. And here's my email address if you want to contact me. We're doing Unit 7, Lesson 4, which is horizontal stretch of a function in Common Core Algebra 1, the non-regions class. We are stretching like a cat. If you don't understand what I'm saying, you can just scan that QR code and listen to the guy who made these worksheets, and he'll explain everything to you also. So perhaps one of the hardest transformations of functions occurs. I'm not sure about that. If this is a difficult one, when we horizontally stretch and compress something. Yet these types of transformations can be vital, especially when we model the process over time, and we can shrink the time interval. Let's first explore using the absolute value function. So here is what we're going to call f of x. Okay. Now lots of things are happening. Number one, first thing that we're doing, the vertex is moving 2 to the right and then down 3. Okay, I get that. Using your calculator, sketch the graph of f of x right here. And there we go. There's a sketch. I tried to draw a little bit of a scale. It doesn't have to be perfect. Okay. Now, what we're going to do is we're going to consider the function g of x. So this is f of x. Better label it. Now, what's happening with g of x? It's saying take the function of f and evaluate it at 2x. What? Here. Everywhere you see an x in the function f, put 2x instead. Everywhere you see an x, put 2x. Okay, there's an x. I'm going to put 2x. G of x equals absolute value of 2x minus 2 minus 3. Determine the formula for g, then graph it. Got it. There's my graph. This is g of x. And I want you to pay close attention to the fact that it crosses on the inside. The x-axis crosses on the inside of this other function, and yet the vertex is the same height, a little bit to the left. It says now consider the function f of x of 1/2 x. F of 1/2 x. There, that's better. H of x equals f of 1/2 of x. Determine the formula for the graph. Well, again, everywhere I see an x, I put 1/2 x. So h of x equals absolute value of 1/2 x minus 2 minus 3. Got it? H of x equals 1/2, absolute value of 1/2 x minus 2, close absolute value minus 3. Now, let's graph it. Here's the graph of h of x. Now, the vertexes, this one is about 5, negative 3. This one is about 2, negative 3. And that one is about 1, negative 3. So let's summarize some things. The turning points. Okay, these are, there we go. Those are the exact turning points. I found those on the calculator. What stayed constant about the turning points and what changed? There you go. The y value stayed constant. The x value changed by the reciprocal of the factor. Oh, reciprocal of the factor. So reciprocal of 1/2 is 2. Okay. See, the original turning point was 2. And so the reciprocal of 1/2 is 2. So 2 times 2 is 4. The reciprocal of 2 is 1/2. 1/2 of 2 is 1. Got it? Reciprocal. Same thing as putting it over 1, then flipping it. If you don't understand, make sure you ask me. Let's see what comes next. Oh, this is the mathematical language of what Mr. Bryce just said. The function f of x, f of k of x represents the horizontal compression by a factor of k. The function 1 over k of x represents the horizontal stretch. Okay, let's do the next page now. When we look at a quadratic function, which means we just have an exponent of 2, determine the coordinates of its turning point by using the equation of the axis of symmetry. X equals negative b over 2a. Extremely powerful. So we know that b is negative 12, and we know that a is 1. So the x coordinate is x equals negative 12 over 2 times 1, which is 6. That's the equation for the axis of symmetry. You know what? I want to find the y value also. So I know that it's not asking me to do it, but we're going to find f of 6. So it's 6 squared minus 12 times 6 plus 20, which equals negative 16. Sorry, I'm trying to get rid of this cough. It was cold. So the turning point is 6, negative 16. If g is defined by g of x equals f of 3 times x, what should the coordinates of its turning point be based on the previous work? And explain. So how are we going to think about this? Well, first of all, we know that the equation is going to be everywhere I see an x, I'm going to plug in a 3. So it's going to be 3x, sorry. So it's going to be 3x squared minus 12 times 3x plus 20. 9x squared minus 36x plus 20. Okay, so let me take a moment here to explain this question. If g is defined by g of x equals f3 of x, f of 3x, what should the coordinates of its turning point be based on the previous work? Based on here? Based on what? Based on negative b over 2a? What are you talking about? Are you talking about the absolute value question? Well, here, I'm taking a look at this and it's like, what's going on? So I did the negative b over 2a, and that equals 2. Okay, that's the x value. So then I talked to a very smart math teacher, Miss Cody, down the hall, and I'm like, I don't understand what this person is trying to do, because we know as a parabola, when you stretch it, the vertex doesn't move directly to left or right, but it moves left and up or right and up. So she said, why don't you put the equation in the vertex form? Here's the vertex form. We can see the vertex is 2 to the left, to the right, sorry, 2 to the right, 2 to the right, and 16 down. And that's the stretch. And lo and behold, negative 16, that's the shift down. Negative 16 is the y value. That was the shift down. So it should have the same height. It's the same y value. Sorry, I keep on getting interrupted by people needing some help. So again, let's try to understand that, Miss Cody, she told me to put it into vertex form, and let's see what happens. So I put this into vertex form, and we see that it does still have a lowest point of negative 16. Okay, so they both still have the lowest point, and this shows a stretch of 9. Okay, so that's pretty neat that we take the 3 and we square it, and it gives us a stretch of 9. So we can tell what our turning point is going to be. It's very nice, putting it in a vertex form. Okay, so it says to use the formula for x equals negative b over 2a to verify this. What I'm also going to do here is I'm actually showing you completing the square, put it in the complete square form. So over here, once a equals 1, we know b equals negative 4, 1/2 of b is negative 2, and 1/2 of b squared is 4. So what we want to do is we want to add half of b squared, because this is called completing the square. to both sides. And this is going to be 4. And now this part factors right there into x plus x minus 2, sorry, squared. And if I want to subtract the 4, I'm really going to subtract 36 over 4, 36 over 9. Okay, and subtract 36 over 9 on this side. And what do I get? I get x minus 2 squared minus 16 over 9 equals 0. I don't like that fraction. So why don't I multiply everything by 9? 9 x minus 2 squared minus 16 equals 0. Oh, okay. So that gives me in vertex form, and I can tell you where the turning point is and that it is indeed stretched. Okay. Okay, this question says, show that the y-intercept of both f of x and g of x are the same from a horizontal dilation. So that is 20, okay? And this is 20 when we have it in standard form, not vertex form. So the fact that, I'll use green. The fact that the equation is 3x squared minus 12x. I gotta get room here. There we go. So the fact that I have the 20 here, and if I plug in 0 for x, I have a y-intercept of 20. Okay, and the original one had a y-intercept of 20 for the same reason. Show that the y-intercept of both are equal. What does this make sense? Does it make sense from a horizontal dilation perspective? Horizontal meaning move something from left to right. No, it's not just from left to right, but it also has that stretch. So since it's moving to the left, it has to stretch more to get to the vertical spot. We can truly investigate why this is happening by looking at the function that is only represented graphically. If there is one thing, and only one thing, that you learned today, it is this question right here. Evaluate each of the following using the definition of G, then state the point that lies on its graph as a consequence. Okay, so G of x equals f of 1/2 of x. What's that mean? That means that this number, this answer right here, first of all, I'm going to put the answer, the first part is -6. That's very easy. Just right there. Now, it says, take it and look at 1/2 of -6. Take a look at the function f. Where's the function f? There's f. And look at, okay, what's 1/2 of 6? -6? That would be -3. So I take a look at where -3 is. So what is the function's value at -3? Let me see, -1, -2, -3, whoop, right there. 1, 2, 3, 4. Okay, so the answer is 4. Where do you put the answer? Right there. So now if I wanted to plot that, I would plot the point -6, 4. -1, -2, -3, -4, -5, -6, 1, 2, 3, 4. Right there. The one thing I want you to take away from this is the fact that this is f of 1/2 times -2. The function value of -1. So the answer is -2, comma, what's the function value of -1? -2. There it is right there. See? Yeah. -2. G of 6 is the same thing as f of 1/2 times 6. That's f of 3. So the answer, 6, function value at 3. 1, 2, 3, negative 2. Wait a minute. You see a pattern here? He's checking out the vertices. So now what's the function value g of 8? Let's see. Function value g of 8 is f of 1/2 times 8. Where in the world am I getting these 1/2s from? The original question. Take half of it. Take half of it. F of 4. Function value of 4. 1, 2, 3, 4. 1, 2, 3. The answer is 3. So the point is 8, 3. Now, like I said, why don't we graph these? So I already graphed the first one. It's negative 2, negative 2. And then we have 6, negative 2. And then we have 8, positive 3. Same shape, just stretch to the left and right. And I just gave you the answer to B. Same shape, just stretch to the left and right. And you know what your homework is? The next 2 pages. If you have any questions, just ask. This is Mr. Bryce, signing out.